Hey folks, welcome back. This is Joel, and I'm back with another video on SDWAN. Uh, so I think you probably would have checked out the rest of the videos on this series, and you probably would be wondering uh, where is the video on local data policy, right? We have touched upon the local control policy, centralized control policy, as well as centralized data policy, right? So this video basically would completely sum up the whole policy space of my estimate, right? So we'll discuss about the local data policy today, right? And just to brief on what we have done, right? So we have the whole SD-WAN setup, right, with two transports. One is the internet and one is the MPLS. We have brought up all of our controllers, all our edges are working fine. There is like a OSPF protocol running here behind on the headquarters one, right? Thereby we are able to kind of like advertise the OMP routes into the switch so that the switch also is reachable to all the other remote sites. And right now, as of now, we basically have kind of like a full mesh setup, right? So every time I start my lab, I basically reset any kind of policies, so that we have kind of like a full mesh kind of a setup. And that's why you basically see this. So that's the current situation, right? So from this point onwards, yeah, let's go and discuss about the local control policy. Sorry, local data policy. My bad. Let me just write it down here. It's going to be local data policy. Now to double click on this, we will actually look into, or we will start by looking into QoS, right? So QoS is basically something which we will configure using the local data policy, right? Awesome. So that said, I'm obviously not going to spend a lot of time on explaining what QoS is, because I expect that's something which the readers or the viewers here can learn it themselves, right? The traditional QoS, right? So I expect the viewers to have a little bit of knowledge about the QoS before you can stream through this video, right? But just to give a minute of brief, right? In QoS, what happens is quality of service. In a traditional QoS, you have a bunch of let's say steps, right? The reason why we do QoS is something like, say you have a router, right? You have a router, and there's always possibility that it is going to be overloaded, right? So it's going to be overloaded with a lot of data, and there might be data coming in from multiple interfaces. There might be a lot of streams, a lot of flows, right? How does the router handle this, right? Will it drop all the traffic whenever it gets overloaded, or will it do some kind of buffering, right, before it can send out, right? So all of that is basically covered in what we call as the quality of service, right? So that said, there are a bunch of steps which are involved in QoS, right? So I would say, give me a second. Yeah. So I would say the first step would be basically the classification, right, of traffic, right? So let me just write it down here. It's going to be the classification, right? So what happens in classification is you try to uh, understand what kind of traffic is flowing through a device or in your network, right? QoS is not something which you just do it on a device, you do it end to end on the network. So you try to understand what kind of traffic. Is it some kind of a video traffic, or is it a voice traffic, right? Or do you have some kind of business application traffic, right? So you try to classify, and some of the tools which you use for classification are generally your access list, right? So using your access list, you kind of try to classify what kind of traffic, right? So once you have classified, you also sometimes go and do what you call as marking. Now marking is important because you wouldn't want to do classification at every stretch, right? So you have this as your path, right? This is your routers, right? You wouldn't want to spend cycles on every single router to classify, right? Putting an ACL over here, putting an ACL over here, putting an ACL over here, it's going to be cumbersome, as well as from a configuration point of view. At the same time, too much processing power, right? So that you have to write, the ACL has to work at every single router to classify. Rather, what you could do is you classify at the entry point. Maybe if the traffic is coming here the first time, you can put in an ACL and kind of like classify. And once you have classified, you can also mark it here, right? Mark the traffic, mark it with some certain certain identifiers. Let's call it as identifiers, right? Ideally you use marking, layer 2 marking, you can use the COS feeds, or layer 3 you can use the TOS feeds, right? I'm again not gonna double click on what these fields are. These are basically your header fields, right? So you mark that way. What now you can do is you don't have to write these ACLs at your you basically don't have to write these ACLs at every single router, or every single, or you don't have these ACLs to it won't consume any CPU. And as a result, once you have marked the traffic, you can just directly put in your QoS policies over here, which will just act upon this traffic which is coming tagged, right? So you don't have to spend a lot of cycles. So that's your marking part. Now once you're done with marking, what else? So you have identify your traffic, you have probably marked it as well. Now comes the interesting piece where you do some kind of policing, right? So policing is where you have now identified the interesting traffic. So you use policing to define some actions, right? You basically say what the router should do if the traffic, if the traffic which you have marked and classified in this way, if it is say violating something, if it is violating if it is exceeding, if there is a burst of such traffic, or if the rate is violating the rate which you have set, right? So this is where you define the actions. Do you want to drop it, right? Or do you want to do something called remarking, right? So there are a lot of things. So this is the place where you define your actions. Next, so once you have done with the policing, so I would say policing, and there is also something called as shaping as well, right? Something which comes in the same let me say in the same stage as this, right? So you can either go for policing or you can either go to shaping. Shaping is something very similar to policing, but the difference is that in shaping you will not drop the traffic, right? Rather what happens is, or maybe if I use a diagram, I think that'll be easier. So when you're talking about policing, imagine your traffic is something like this, right? And let's say you have a hard stop at this place. So whenever the traffic exceeds the hard stop, it is going to be dropped, right? This is going to be dropped, and that is basically your policing. Now your shaping is nothing but something like this, right? So you have a threshold, right? So let the traffic increase, but say this is your threshold. You basically don't ever allow the traffic to cross the threshold, right? So whenever it hits the threshold, what you do is you try to buffer it, right? Or you store it in what you call as queues, right? So that you can just buffer it in this way. All the extra traffic can be buffered, and you can now send like a consistent stream, right? So in this manner, or in shaping you basically don't drop it, right? So that's the difference, right? That said, so that basically brings us to the very interesting topic next, which is your, let's say, scheduling, right? Because like I said, when you're shaping, you have to somehow make sure that the traffic which is crossing the threshold is kind of like stored somewhere in some kind of queues, right? So if it is stored in some kind of buffers or queues, and then how do you handle these buffers, right? Do you want all the buffers to be given the same preference? Do you want some buffers to be given higher preference? Or I'm using the word buffer, so buffer and queues, I'm just interchangeably using it. I mean to say the same thing, right? So that's basically done in your scheduling. And the last part, again, not a very mandatory part, but I would still call it out, which is your rewriting, right? So rewriting is again where what we do is uh, I mean, while doing all this QoS, especially while doing the marking, you probably would have let's say uh, you would have put in some kind of, you would have changed the TOS fields or COS fields, right? So in rewriting, what you can do is you can kind of like change those values back again. Maybe your service provider has a requirement for you to use a certain DSCP values, right? So you can rewrite the values back again, right? So that when the data basically goes from the enterprise, when it is goes to this service provider, maybe over a MPLS, right? When at the exit, right, mainly at the VHS, if you do this, what will happen is your values which you had earlier used, let's say you had changed to some DSCP values inside your enterprise, you are now changing it back to some other values which your SP service provider requires, right? Because he also would be doing some kind of QoS on his MPLS network, right? So he would probably have some requirement telling you that, hey, I would want this particular DSCP value to do my QoS, right? So if that's a requirement, you can then do something called as rewriting, right? So that's basically my whole, let's say, the whole stack, the QoS stack, I would call this, right? Just get rid of this, right? So that's your whole QoS stack, right? I wouldn't probably, I mean, everything you do in any platform, in any Cisco platform, right? Be it Nexus, ISXR, XC, everywhere, you're basically fiddling with these steps, right? It probably, you basically maybe calling it in a different way. There might be different names for each of them, but at the end of the day, this is literally what you're doing everywhere, right? The configuration again might be different in different platforms, but the basic funda would basically the same, right? That said, now coming to SD-WAN, right? That's our whole idea today. Now, how do we take this QoS from here and kind of configure it in our network, right? So that's the whole agenda. So let me start by putting in some simple diagrams, right? So let's say I have the router. So let's keep this for reference over here. This is going to be my VH. So this is the router. And obviously on the router, I'm obviously going to have some kind of an ingress. Let's say this is my ingress and this is my egress. Now, all these steps, let me just write it down here. So we are going to have classification, and maybe use a, right? So we're going to classify. Then we are going to have something called police, right? So that's needed. And after policing, so that's going to happen on the ingress. On the egress also, you can have policing. So I'm going to write this here again, right? You're not going to classify on the, you probably would not classify on the egress. I'm not going to write that. So you're going to have classify and policing, on the ingress, policing again on the egress. Then the scheduling also comes here. Scheduling, obviously, it is in the outbound direction, so in the egress, and then the rewriting, right? Rewrite part, which we discussed. Okay, so we just pull this aside, right? So maybe this is better, or maybe not. Okay, so this is good. So this is what we have on the ingress and the egress side, right? Now, how do we achieve this? Let me just probably color it. So this can be done using my, localized data policy. This also can be done by localized. This is also localized, localized, and localized, right? So all these steps which I've shown here can be done using your localized data policy, which we haven't explored yet, which we'll be exploring in this video. Okay. Now, that being said, you also have a provision to do, say, something like classifying. So I'm going to write classify again here. Classify and police, right? So you have a flexibility to do the classifying and policing using your centralized data policies as well, right? So these two, I'm going to use different colors, right? So you can do it using centralized data policies as well, right? So it's not limited that you have to do this. I mean, well, again, right, if you do it on this centralized data policy, it's going to be applied for the whole SD-WAN fabric. You do it localized, it's going to be applied only to the device. That's the only difference, right? Awesome. So now that we have set the context, I think we are in a good place to get started with some of the basic things. So yeah, let's not dig into too much details starting. Let's get our hands dirty, right? So let's start. What do we do? First is let me see if my vManage is up. Give me a second. So I have my vManage over here. Yep, my vManage looks good. So what I'm going to do is, for this exercise or for this video, I will not be using my MPLS, right? I want all my traffic to go through the internet so that I just have one, interface, one local interface. I don't want two interfaces, because if I have two interfaces, then the traffic is going to be load balanced, and it's kind of like little difficult to test our results and all of that. Okay, so I really don't want the MPLS segment, so I'm probably going to shut it down. Right, so I'll go to my R MPLS and I'll shut down this interface Ethernet 0/2. There you go. So once I've set it down, now I would obviously lose the MPLS connectivity to my BR3 side. We'll mainly be using the BR3 side for all our testing, so I'm just going to do it here. The 0/2 is shut down, so I'll basically lose the connectivity, and in a matter of few seconds we should start seeing some kind of control connections going down over here, right? All right, so you can see now you have some kind of faster connectivity, but that's expected because we shut down one of our MPLS connection. Okay, awesome. So next, what do we do? So next is, let's look at our diagram again. So here we have BR3 and I have a branch 3 Windows machine, right? So you can see I have 3 machines. One is branch 3, one is headquarters, another one is my management. So let me go to my branch 3. So this is my branch 3. So I've set up 2 protocols, right? One is my CIFS protocol, CIFS protocol, basically a file transfer protocol. And the other one is my, what do you say? Let me just close this. So I have my CIFS here, this window, and this is my FTP. So I've connected FTP to my headquarters, right? So this is my headquarters, and this Windows PC over here is my headquarters, and this is my branch 3 PC, right? So between these both, I have a couple of protocols running, which is one is my, like I said, FTP, and this is my CIFS. So before we do anything in QoS, it's better to start with a benchmark, right? And we are going to do a benchmarking now, which means, so what I'll do is I'll just take a particular, I have some kind of data over here, and let me try to upload this data using CIFS. So I'm uploading to my headquarters right now. Let's see. So when we do that, copy but keep both files. Okay, let's see the speed, or let's see the bandwidth which is being used, right? So you can see here it's around 204 kilobytes per second, right? 204 kilobytes per second, right? So which is okay. So this is like our current speed, right? Let me probably cancel this. Let's also check from a FTP point of view. So I have a FTP client here connecting to the same headquarters, and let me try to upload the data, and let's try to see the bandwidth here as well. So let's see the speed here. Here as well, you see something like 329, 350, 345, around at an average of 300, 350, right? Awesome. All right. So what I want to do now is, let me probably delete this. So we have seen that in both of these protocols, the bandwidth which is basically used, or the speed at which the data transfer is happening, is around 200, 300 kilobytes per second, right? So I want to limit this to say something like 125 kilobytes per second, right? I don't want more than 125 kilobytes per second. So let's basically use that as a baseline. So using this QoS, we are basically going to kind of like use probably 125 kilobytes per second, or which is also equal to 1 MB, 1 megabits per second, right? So that's going to be our this thing. So let me probably write that down as well, so that we don't forget. That is that, right? So what we have realized is that our network, we want to kind of like limit the data transfer at we want the data transfer happening at say 1 megabits per second, right? 1 Mbps, which is also equal to something like 125 kilobytes per second, right? I think that makes sense, right? You take this 1 kilobits, because 1 byte is 8 bits, you just multiply this, you basically get the 1 megabits per second. So this is what we want, right? This is This is where we want to kind of like limit, right? So we will be doing that using QoS right now. Okay, awesome. So now that we have done with that, so let's start with the first step, which is the policing. So just observe the just observe the order which I am going to configure this, because the order is something which is going to be very useful for you to understand as well. So I'm going to start with policing, right? The policing part. And yeah, so I think it's good. So let's go. Let's go and start configuring. So let's go to the management. Let's go to obviously policies. And since let's just see that all the other older policies are deactivated, great. Now let's go and create some kind of list. Observe, I'm going to use localized policy because it's a localized data policy. So once we are here, what do we do next? All right, so here we will basically go down to, you have a list called policer, right? And we will go and create the policer for 1 megabits per second, right? So let's call it as police underscore. We don't want, so we want to limit it, right? So let's say 1, the big M corresponds to mega. So 1 megabits per second, which is 125 kilobits per second, kilobytes per second, sorry. Great. So the burst, I would probably keep it as again 1 mega itself. So I believe it is 6 zeros. Hope I got 6. Yep, that's good. If it exceeds, right? So this is the actions which I was talking about. In policing, you define some actions. We are saying if it crosses this particular limit which I have set, if it exceeds, then I'm going to drop it, right? If it crosses 1 megabits, we are basically going to drop it. And the rate, so this is where we have to define, which is 1 mega. So it is 6 zeros, 1 2 3. I think that's good. 3 and 3 6. Hope I got 6 3 3 6. And let me check this as well. Yep, that's good. So let's add this. Now once that is done, let's go back to the diagram, right? So what we are doing is we are doing it here, right? We are doing it for BR3. And we want to limit the traffic which is generated, say, from switch 2, right, in this direction. So next is we need to go down to our interface, right, the VLAN 10 interface which we have here, and we will have to go and put in this policer which we just now defined on this interface, right? So for that, we will go back here. Let's go to my let's go to templates, and let's go to features. Let's try to find the VLAN. Right, so here, up here, you'll have to search for that VLAN 10, right, which we created. When I say VLAN 10, it's basically this one over here. So I believe we have the sub interface created from the older template. So let's go. This gigabit 0/2.10. Let's pick this one. Let's edit this. Basically, we are trying to attach that policer which we created earlier down here to this sub interface, so that it comes into effect, right? So let's go to ACL. Let's scroll down a bit. So here you'll find an option called ingress policer, because we're applying this on the ingress side. Let's turn it on, and here you need to mention the name of the policy, let's say policer which we have defined earlier, which is police underscore 1 mega or 1 M. So let's update that. Next, so it's going to go on 2 devices. It's fine. We are basically testing it only on VR3. So once that is done, we'll be able to test. Let's wait for this to happen. All right, it's completed, which means now I can go and test. Let's go to branch 3, and let's try to upload this data to headquarters using CIFS, right, CIFS protocol first, and let's see the speed. Remember earlier it was, before putting the policer, it was somewhere around 250 300 kilobytes per second, right? But now it should actually come down to say 125 kilobytes per second, or 1 MB megabits per second. So let's do that, and let's see the speed down here. Okay, it's 170. Earlier, I mean, when it starts, it's going to be a little more because of the burst traffic. Let me just pause this for a second until it goes down. All right, see now it has stabilized, and you can see it is getting policed at less than 125 kilobytes per second, right? It's somewhere very close to 122, 123, right? So this is what we have achieved. Let me cancel this, and let me also show you the same thing while doing FTP as well. So just to make sure that these two are two different protocols, right? You can see here this is using the CIFS. So right now I'm trying to do the same thing using FTP as well. Let me refresh this. Let's try to go here, and using the client, let me try to upload here. Try to new name, say define. Let's see the speed. So like I said, initially when it starts, it's going to be a bit much, but it should stabilize. So it's going down. 224, 182, 165, 136, 111, 120. See, it is stabilizing around that number now, right? If we leave this for some time, it should actually get back. There you go. I left it for some time. It's somewhere, between 116 and 120, which is very close to what we have said. All right. So we have actually put in the policer, and it is working as expected. Let me cancel this. So let's get back. So we learned one way of doing the police operation, right? But there are actually multiple other ways or multiple other options to accomplish the same thing as well, right? Before that, let's also check the traffic which got dropped, right? So we can go down to BR3. Let's clear the screen a bit. So what we could do is we can probably run something like, I believe it's show system statistics, if I'm not wrong. Statistics, yeah. And because it is an indirection and policer, or wait, policer, I believe, yeah, it should work. Okay, there's some issue with my. All right, so here, I know the include the option doesn't seem to work for some reason. Anyway, so you can see here on the output, you can see there is the policer drops, right? So that's exactly what I want to show. Because we have put in this policing, it is dropping the packets. Probably there's another command on the interface level as well. Show interface. If I do something like detail gigabit, I believe it is 0/2.10, and if I check drops, there you go. See, you can see the RX drops, right? So the packets are getting dropped, right? So that's exactly what I wanted to show, because it's getting dropped because we have put in a strict policy, and we are saying anything more than 1 megabits per second we have to drop, right? So that's exactly proving our point. All right, now let's go and remove that particular policy, because as I proceed to the next step, I don't want to keep that up. Hope I've canceled this. This refreshed. Let's probably delete this. I don't need this. So while that is getting deleted, let's go and remove the policy from here. Right, so I'm just going to go down to the feature template where I enabled it earlier. So let's go down to this place over here. Let's edit this. Let's go to the ACL section, I believe, here, and it should be somewhere here. Okay, so let's probably change this to default, and the default is off. So we are updating this, basically undoing whatever I did just now. Let's confirm this. Awesome. So while that happens, let's go to the next step. What are we doing next? So I actually showed you one way of doing the policing, right? Where we basically went and applied this directly to the, we directly applied it to the interface, right? The next way of doing this is, applying this policing to the something like a class map, right? Or to the traffic class, right? Right now, we did not have a way to apply this policing only to say FTP or CIFS. Whatever we applied, it basically went on to the whole interface, right? So let me just go on writing down the stuff which we are completing, so that's easier to recollect later. So we did it. We applied this per interface right now, right? So this is something which we did. The second thing which we are going to look at is applying per traffic class, right? So this is what we'll explore now. So how do we do this? Again, pretty simple, pretty straightforward, right? So we go back to my, so let's go back to the control. So let's go back to the policies, and let's go to something like access list. Let's go to access list. So on the access list, let's create, we haven't used any access list before. Let's create a new access list, IPv4 access list. Let's call this ACL from where? From the VLAN 10, right? So it's from the service side. So let's apply this. Let's create a sequence and add a rule. What are we going to match based on? It's going to be the destination port, right? For CIFS, it is 445. And the protocol will be the TCP. So it is 6 port numbers, protocol number is 6. The action is going to be accept, yes. Let's put the polisher here. So you click on the polisher, select the polisher which we created earlier, right? The 1 megabits per second, right? Do we want anything else? Probably let's put a counter as well, right? Let's call this counter as maybe police underscore, we'll call this as 1M underscore CIFS, right? We are basically putting this only for CIFS. So what we are doing right now is we are putting this policing condition only for the CIFS traffic, whereas for FTP we don't want this, right? So we'll go and save. I think we'll have to add this first. Let's add this, and the default action, obviously I will have to keep it enabled. So default drop is basically accept, right? So the rest of the traffic, basically this is for the rest of the traffic which doesn't match, right? It should still be accepted, it should not be dropped. So that's why I'm enabling that. That being said, let's save this. So we have created this amazing access list. Now we need to somehow, put this access list on my device first before referencing it. So we'll use one of our old policy which is over here. Which one do we use? So I think we have some kind of a BGP policy, with the 4 devices attached. So we could probably use this. So let's go to edit. Let's use one of the policy. We are basically piggybacking here, right? And nothing else. So we're basically going down here. Let's click on access control list, right? Let's go and import the policy which we just now created, right? So ACL from VLAN 10. Let's import this. And once that is done, we have imported the policy, and what else do we want? So that's it. I mean, if you want, we can preview this, right? So this and all is from the older policy. We basically have this one, right? So this is what we just now added. Sorry, this one, the access list right here, right? So that being said, we are basically going to save this. Remember, as of now, we are just basically, we have created access list and we are trying to just add the access list to the device, right? And obviously this will go and add it to all the 4 devices, I believe, because we have 4 devices attached, but that's fine, not an issue. So access list, just putting the access list on the device is of no use, right? We need to somehow make this access list, we need to attach this access list to the interface, right? Only then it will have value. So for that, we will have to go and add it to the interface just like we did earlier. So let's do that once this is completed. All right, so this is completed, which means now we are good to go to the templates. Let's go to the feature. And here, let's go back to the same thing, gigabit 0/2.10. So this is sub interface corresponding to VLAN 10. Let's edit this. Again, go to the ACL section, right? So again, here you will basically have to, earlier we went to the ingress polisher, but this time we are going to go to the ingress ACL. So let's turn this on. And once you turn this on, we'll have to mention the ACL name. So for that, it's better to go to the device and check the exact name of the ACL. Let me clear this. So the ACL would have come on the device by now. See, this is the ACL. Let's copy that and let's go and paste it down here. There you go. Remember, the names should exactly match, so that's why I'm just copying it from there. So once we're done with that, we should be able to update this. Again, I believe this will go on a couple of devices, which is fine by me. Let's wait for this to complete. Yep, that's completed, which means we should now be able to see this. Let's run the same thing again, and there you go. We see that this access list has been applied on this particular interface, the sub interface corresponding to the VLAN 10 in the in direction, right? So that's pretty good. We can also see the counters which we define. So I believe it's show policy access list counters, I guess. Okay, so there you go. We have the counters and the bytes as well, right? Anyway, so once we are done with that, it's time to test. Let's also see the other stuff, right? Do we have one more show command? I think I'm expecting the policers. Do we have the yeah? There we go. So we have the policers as well, right? So this is where it kind of connects the access list to the policer which we have defined, right? So we are basically saying the traffic which is matching this particular access list, it has to be policed to 1 megabits per second, right? That's basically what we are saying, right? So now let's try. So let's first try with the traffic that will not be polished, and which is that is our FTP traffic. FTP traffic will not be polished. So let's go and try to upload this. Right, so you can see the speed is 320 bytes per second, right? And even if we keep this for some more time, I think the speed is going to remain the same, but just to be safe, we can try that. All right, I've kept it for some time and still the speed is not reducing. It's somewhere between 330 340. It's basically more than 300, right? So it's probably reducing a bit, but see, you can see it is again increasing. So it's somewhere between 250 300, which is fine, and it is not getting policed. So let's cancel this. Now let's try the same thing on the CIFS traffic. The CIFS traffic is basically something which we have enabled the policer for. So that's when we enable this, or when we send this data, we should see uh, that the speed should get truncated to 125 kilobytes per second, right? Again, let's wait for first couple of minutes for it to get stabilized, because like I said, initially there will be some kind of a burst traffic which will go at a higher speed, but after that it's going to go down. All right, now you can see the speed has gone down. It has stabilized to like something less than 125 kilobytes per second, right? Which is exactly what we set out to do, right? Let me cancel this. Here also you can see on the device you have these counters. So using these counters, now you can track as well. Something like, if I look at the access list counters, you can see the access list bytes getting matched, because the traffic is getting matched. The other one is for, give me a second, the policers, right? You can see the counter which we had enabled for the policer as well. So even that is able to track that, track the bytes which are getting policed, right? So that's pretty cool. All right, so that was second way of doing it, right? That was second way of doing the police operation. We did it per interface, we did it per traffic class. So we'll go to the next one, but before going to the next one, let's go back to the boring part where we go and remove the stuff from our device. Sorry, I'm just showing that part as well, so that if anyone is following the lab and doing it along with the video, they can like they don't get lost, right? So to do that, we will have to remove the ACL. I think that's more than enough for us. So what we could do is probably go down to policing again. We can go down to the policies, and here you can basically go down to say something like, I think, access control list. So up here you can select that particular access list which we created, take this one, edit it, and I think we can probably blindly go and delete this. So we can just go and delete this, because if you remove that, the access list will not have any power, right? We have basically removed the matching condition, and by default everything is enabled. So we have removed the policing option now, right? There you go. So this will be pushed back to the device. right? So while that is happening, let's go to the third use case, or the third way of doing it, right? The third way of doing it would be by using a centralized policy, right? So the third way of doing this, the same, let's say, function or the same functionality can be also realized using centralized data policy. Till now we did, localized data policy, but now we'll be doing it using centralized data policy. Awesome. So for that, let's go back. Let's go back to my. Okay, this is still happening. All right, that's completed. So let's go back. Let's go to policies again. And on the policies, let's go to this custom action over here. And what do we do? So we will go to the traffic policy. So once we are on the traffic policy, uh, so this is the data policy, right? So let's go to the traffic data. Okay, there is something which is already there, so we are going to basically use this. So let's, I mean, this is probably from one of my previous video. The data, I think we have used it in our centralized data policy, right? I'm just going to piggyback my new stuff on the existing policy instead of creating a new policy from scratch, right? So we have some stuff here, so let's just go and delete this, not needed, right? So the default is accept. Awesome. So what we'll do now is here, let's go and probably add a new sequence type, which is going to be a QS, right? And the sequence rule here will be what? Let's go and match based on the application, right? So because we want to do this for the FTP, let's go and select for, I believe I've already created some kind of a, you see here, I already have an application which I created for this, I believe for the application aware routing video. So I'm basically going to use that. You can create a new list of this as well. So this particular list has, you can see here on the right hand side, you have FTP and FTP data, right? So this will be able to identify that. So that's cool. So what we want to do is we want to go and put in, we are basically right now using DPI for this, right? When we are basically using this option, you are internally using deep packet inspection, right? So that's another use case which I wanted to show you how you can use deep packet inspection with QS, right? So this is cool. So we have now identified the traffic to be FTP traffic using this. Now the actions part, we will probably have to go and accept this, which is all right. Let's use the polyser and use the same 1 mega, whatever, 1 megabits per second, which we have. Probably create a counter as well, so that to identify the packets which are getting dropped and stuff, right? So we can have polyser underscore 1m, and we can say app underscore biz. So that will help us understand that, this is something which we created using centralized policy. So let's save this, right? That's pretty cool. Let's go and save the data policy. Okay, so once done with that, I believe this data policy is attached somewhere, so let's go and find that. I think it is attached to I think let's go to the centralized, I think it's attached to the central policy over here. So let's go and activate this. Before activating that, let me show you that it is actually attached over there. So let me show you. Let's edit it. Right. So here you should probably find it somewhere here under the traffic data. Right. So under the traffic data, you can see the data from service. Right. So you can see this policy or this rule here, and you can see it is getting applied to all the spokes and the VPN list as well, which is perfect for us. Right. Awesome. So let's save this. So while doing that, it will. Okay. Now we'll have to go and activate it. Let's activate it. This because it's a centralized data policy, it will be pushed to the vSmart. There you go. That was successful, which means now I can go down to my device, which is say VR3, and if I do something like show policy from vSmart, right? We've used this before. So you can see here this policy has arrived here, right? You can see the polyser and all of that, right? Which is pretty perfect. And what else do we want to see? You can also see something like show policy the counter basically, right, which we created. So if you want to see that data policy filter, and you can see the counter is available here, right? Awesome. So that being said, now what we have done is we have basically applied this policy operation on only the FTP data or FTP protocol, whereas not on the CIFS protocol. So the CIFS should work fine now, whereas FTP should not work fine, right? So let's try that. Let's see if everything is good here. So let's do the faster one first. So CIFS should not get truncated, or it should, the polisher should not act upon. So let's go and push this, and we should see the speed being more than obviously 125 kilobytes per second. All right, let's see the speed. Okay, so it's starting with 170. We'll wait for some time. It should be more than, obviously, it's obviously already more than 125, but I'm pretty sure it's going to be more than 200 as well. So let's wait for a minute or so. There you go. You can see it has increased, and that's why, that's what I wanted to show here, that CIFS is not getting, the policy which we have put, the polisher is not getting applied on the CIFS traffic, and it is, the CIFS traffic is obviously going at a higher speed than 125 kilobytes per second. So let me cancel this. So now let's do the same thing on the FTP, right? And since we have enabled the polisher on the FTP, this is where, the speed should get truncated to less than 125 kilobytes per second. Now, okay. So the thing with the deep packet inspection is that, it's a little tricky because um, deep packet inspection needs a little bit of packets initially to understand what kind of for it to do its investigation as to what kind of data it is, right? So that's why initially you might, sometimes if you're trying this on your lab, you might find this guy using you know I mean, probably for a larger amount of time, it might be more than 125 kilobytes per second. In my case, you see it has already realized that it is FTP traffic, and that's why the polisher is getting already acted upon, and the speed is less than 125 kilobytes per second. But don't be alarmed if this is not working right off the bat, because the deep packet inspection feature itself would need some bytes for it to understand what kind of a traffic it is, right? So there you go. So we have verified this third use case as well, right? Which means we can go and cancel this, right? We can also check the counters now if you want. See this particular counter, it should basically have a huge amount of packets getting dropped. See there we have packets, which are getting tracked and which are getting dropped as well, right? So that's exactly what I wanted to show you, and it is working as expected. Now let's go back and remove the stuff which we have added. Let's go to the policies. Probably let's go to the traffic policy, because we added it as a centralized data policy, right? So if you go down here and if you edit this over here, probably let's edit it here, and this QoS part, let's go and just delete it off as is, and the rest is anyway accepted, so that should be fine. All right, so while that is happening, let's look at the other interesting piece, which is the along with the policing, I think it's also very important that we talk about shaping. So let me show you how we can do shaping in SD-WAN as well, right? Probably let me also color this with the blue here, because that also be something like a local configuration. It's not actually a local data policy as such, but it would basically go into the on the device, and that's why I'm just coloring it as blue, right? It's not something, you don't do this using either centralized data policy or localized data policy, right? And so where do you do this? So for that, we will have to, all right, so for doing this, we basically go down to templates. So on the templates, we will go down to okay, the feature, obviously the feature templates, and let's go to the interface, right? So what we want to do here is we want to do it on the outbound interface over here. All the traffic which basically leaves the edge, we want to shape it, right? So we will do it on this gigabit 0/0 interface, which is connected to the internet. So we should probably have it here somewhere. The INET interface, I believe. Right? Oh, it's that probably on all the devices. Okay, there are 4 devices attached. Okay, so that should be fine. These 4 devices, which is VR2 and VR3, let me just verify. Yeah, so we have VR2, VR3, so that should be good. So let's go and apply it over there. So let's edit this. So again, you go down to the section called ACL or QS. There you go. So under this section, you will basically find the shaping rate over here, right? And that's where you put in your value, right? So this is where you do it. So in my case, let's say I want to obviously put it to something like let me think, how much do I want? All right, so let me shape it to something like 2000 kilobits per second, right? So let me do that. 2000, sorry, 2000. Just remember this is in kilobits per second, so I have to mention it in because I wanted 2000 2 Mbps, right? I want 2 Mbps because if you look at my numbers which I've used 1 Mbps for my policing, so I want to shape it at 2 Mbps, right? If something goes beyond 2 Mbps, I can do it because I see there is a bit of traffic which goes somewhere around 200 300 kilobytes per second, right? So let's truncate to that. Let's shape it to 2000 kilobits per second, right? Which is fine. And so that's it. I mean, you just go and enable that and update it. All right, that's getting applied. But let me just write it down here for the reference. Shaping, what we are doing is we are shaping it at, so we are shaping it at 2 megabits per second, which is basically nothing but 250 kilobytes per second, right? It's basically divided by 8. So you get 250 kilobytes per second. So now, since we have shaped it at this, all our traffic, right, should get truncated and it should never cross 250 kilobytes per second. Okay. So let's see if this completed. Yep, that's completed. So we can even test it. Probably let's test with one, maybe like the CIFS traffic or something. So here on the CIFS traffic, let's go and upload it here, and let's wait for. Let's check the speed. I'm just going to pause and let's wait for it to stabilize. There you go. You can see it is getting truncated at 256 kilo, 256, 250 is very close, right? So it's getting truncated or it's getting shaped at 250 kilobytes per second. And that's exactly what we want. All right. So we have achieved the shaping part as well. All right. So I think this is a good time to take a break. I don't want to overburden one video with a lot of information because QS is a very interesting and there's a lot of moving parts. It's easier to get lost if we do a lot. So uh, we'll come back. We'll come back to this. Just to recap on what we did, we just kind of started by discussing a little bit on what QS is and how it is generally working in a traditional network. Right? We talked about classification, marking, policing, scheduling, and rewriting, and obviously shaping as well. And then we started with some use cases. We did close to 4 use cases over here, right? So we did, we started with policing to start with, right? And we tried it per interface. We did it per traffic class. We also saw that the first 2 options which we did were based on localized data policy. So we went and did it on centralized, data policy over here. And then, we also went and tried another operation of QoS, which is the shaping. And we shaped the traffic to something like 2 mega bits per second, which was nothing but 250 kilobytes per second, right? So we did it till here. Yeah, when we come back, we will basically, I think, do the next one, which is going to be the scheduling part, right? Because we have done policing, which is basically covering these 2 pieces around here. The next which we will look into is the scheduling piece. All right. Thanks for watching, guys, and do come back for more videos.